Great. Thank you so much, Hal. I very much appreciate that introduction. I'll be talking, as she said, about We Are Traffic, creating robust bicycle and pedestrian count programs. I would like to thank IBPI for making this possible. I am a researcher at the Oregon Transportation Research and Education Consortium, also known as OTREC, at Portland State University. And I've had the opportunity to learn more about bicycling and walking through count data through my work at Colorado Department of Transportation prior to coming here, and I'll be using that as an example in a lot of the work I'll be talking about. But first, we are traffic. If we really believe that bicycling and walking are modes of traffic, then how is that going to change how we measure those modes? So that's going to be the question we're trying to think about in this webinar and address. We'll start with an introduction, why counting bicycling might be important, why understanding pedestrian volume might be important. We'll talk about what we can learn from motor vehicle traffic monitoring, how we can apply that to non-motorized count programs, and then conclude with recommendations and conclusions. And what I'll be doing today is giving you an outline based on the traffic monitoring guide that was produced in 2013 by the Federal Highway Administration. And it's not to give you all the details that you would need to ever create a program, but just to give you the outline and resources so that you can find more information and as you go forth and start programs and maintain and continue existing programs. This is a growing field, and I hope that many of you have already participated and have great knowledge to share with us. So at the end, we will open it up to questions and comments, and I hope that you share some of your wealth of information as well. We'll start with an introduction. Why measure bicycling and walking? Well, if we don't count it, it doesn't count. If we truly are traffic, then shouldn't we count bicycling and walking as we do other traffic? And what is this going to help us with? Well, most of you are very familiar with these concepts already. So we have the idea of funding decisions that are being made using performance measures. And especially with the advent of MAP 21, we need to know more about performance measures. How do we create those? And so this is going to give us a way to do that. We want to show change over time. We want to understand how many people are using a facility before we build it. For planning, we want to look at short duration counts and see our spatial distribution, but we also want to look at the long-term trends. And here's one I think we often forget, which is economic impact. Some of the people who are most interested in count data are actually the people at the businesses, in retail businesses in our communities. They want to know how many people are walking by, how many people are looking at their store, who might be interested in walking in and buying something. So actually sometimes it's the downtown development commissions that are doing the counting. So that's an important aspect of it, and we found the work of Kelly Clifton at Portland State University has found that bicyclists can actually be a greater influence on economic drivers than we thought before, that they actually are one of the modes that contribute, that purchase more at a store than other modes. So that's exciting. So then public health, of course, we want to understand active health. and having physical activity is part of that. But another one that I think is exciting is safety. That's why I got into this field, because if we want to understand what those crash statistics mean, we need to know how many people are passing through the intersection and what's their exposure to collisions. So we can't really do rigorous safety studies without that kind of information. Okay, so there are many ways to estimate bicycling and walking, and a common metric has been mode share, and that's wonderful. We can get that from national surveys, and that's been a good metric for bicycling and walking. But if biking and walking is really traffic, we need more than just that. There are GPS data, but today we'll be talking about count data. And there are two types of count data I'll be talking about today: permanent count data and short duration count data. And by permanent, I mean stations that are in place all year round, counting 365 days a year, 24 hours a day at the same location. And short duration can mean anything from 5 minutes to over a month of count data. So, and those can be automated, they can be manual, and we'll talk about that in detail. So what good are counts? Why are they better than, or not better, but an additional piece of information we need? Well, funding decisions. I talked to a local MPO here, and they said that projects that they included, when they included the counting of people using their facilities, their proposals were more likely to be funded. So that's important. There's facility level. This is a facility level number. If we want to know what's going on at the intersection, at the roadway level, we need this data. And that can be used for all sorts of studies. If you have a regional model that is accounting for bicycling and walking, then validating that is an interesting thing to do. Prioritizing projects. Once we see where people are walking and biking, maybe we want to increase funding in places where they're already walking and biking. Maybe we want to understand why they're not biking and walking in places that we don't see people. And if you want to compute the bicycle miles traveled, vehicle miles traveled has been a huge performance metric for motorized travel, and bicycle miles traveled could be a performance metric for cycling, and similarly, perhaps pedestrian miles traveled. So that's some direction we could go. I'm going to give a couple examples of how to use this. The work of Srisha Kotori and Peter Kuntz in Portland. Signal timing, simple. We count motor vehicles all the time so that we can properly time the signals in our communities, all the traffic signals. And generally we look at vehicle delay and we want to minimize vehicle delay. Well, if biking and walking are also part of traffic, maybe we should consider pedestrian delay. So that's what they've been looking at, how to do that. And you can't do that if you don't have any count data. Another example, this one's from Colorado. What? People actually bike here? This is a common reaction from many people. We often think, well, I don't see anyone when I go through, so there must not be anyone here. But when you start counting, this one particular location, for example, in suburban Denver, they actually put in a counter 24 hours a day, 365 days a year, and found that there are 200 people on average per day passing through this location. The maintenance people were shocked. They had no idea. They just figured no one uses this. Why should we spend our time clearing it in the winter? But once they realized that people were actually using it, then they started doing the winter maintenance and clearing the snow. Another example, this one's from Oregon. This very suburban location. We've got a 6-lane high-volume highway intersecting another high-volume roadway. Not a pleasant place to be walking or cycling. We did a count there, And everyone was pretty surprised to find we had about 400, a little more than 400 pedestrians per day at that location. So this one person here, this one person is not alone. And sometimes we think, well, I don't want to count people because then people will know that there's only 5 of us. Well, you know what? There are often a lot more than 5 of us. And when we start counting, we realize that this is a group of people that should be included in our traffic volume understanding. Okay, great. So let's talk about traditional traffic monitoring. There are a couple ways. We have the permanent counters that are used for counting motor vehicles, and I don't know if you can see it, but here cut into the roadway are some inductive loops, and there's one under this car as well. The idea being that the electricity is flowing through the loop, and as the car passes over, it's a large metal object, it changes the inductance of the electromagnetic field. So this is not weight-based, this is inductance of the electromagnetic field, and that change in inductance is detected at the detector, and we know that something has passed over it. So that's what they're using for permanent counters often, not always, but often. Another technology is the pneumatic tube. It's just a hose, rubber hose across the road, car goes over it, a pulse of air travels from the hose through the hose to the detector, and we know that an axle has crossed. So very basic technologies, very simple. But these hoses can of course be moved, and you can count 24 hours, 48 hours at a time at these various locations. So here's an example. I'm going to use Colorado as an example. Nice rectangular state, but this allows us to see what a permanent count program might look like for motor vehicles. So these are all locations across the state where we are counting motor vehicles 365 days a year, and those are called automated traffic recorders, ATRs. So great. At all those locations, we know the annual average daily traffic because we just take the total count for the whole year, we divide by 365, and we get the annual average daily traffic, AADT, this metric that we use quite frequently to understand volumes on roadways. But we only know it at the locations I showed you. So they do these short duration counts using the tube counters at all these other locations. So that's blanketing the rest of the state. Now, if that's all the information we had, we still don't know the AADT at all those short locations because we only counted for 24 hours or 48 hours. So what we do is we estimate, we create these factors, these seasonal adjustment factors that tell me how much of the year I expect, how much of the volumes are higher or lower in a particular month. For example, in January, you might expect lower motor vehicle volumes than in July. And you come up with a set of factors from your permanent counters where you know the variation over time. Then you apply those to your short duration counts so that you can factor up. If your count happened to be in January, you can factor it up. If it happens to be in July, then the average would be lower. You factor it down. And you can estimate the annual average daily traffic at all of those locations. So now you have a picture of what's going on throughout your entire network, and you can estimate the vehicle miles traveled by just taking the estimated AADT and multiplying by the length of the segment and compute the vehicle miles traveled. And this is a metric that's been very powerful. Congress has chosen to base distribution of state transportation dollars based on this metric. So this is an important metric for motor vehicles. Can we apply this to biking and walking? So I proposed the metric annual average daily bicyclists for bicyclists, or annual average daily pedestrians for pedestrians. And for the first time in 2013, The traffic monitoring guide, which is produced by the Federal Highway Administration, includes a chapter on non-motorized traffic. This is exciting, and they have given us a format in which these counts should be reported so that it can be included in their traffic database. This is a huge step forward. The rest of the presentation I will be using the basic outline that they're giving us so that we can understand these programs better. And they're kind of structuring it like we do for motor vehicles. So the basic concepts are still the same of the permanent count program and the short duration count program. And I hope this gives you just an introduction to the topic. And you can look at the guide yourself. It's available for free online to find out more information and read it yourself. So non-motorized count programs. This is the basic outline I'm going to be using for today. The most important thing here is we have a permanent count program and a short duration count program, just like for the motor vehicles. By creating these factors, we can estimate the AADB or AADP at all these locations. So let's start by the first step is inventorying. What do you have? What do you have on the shelf? What have you already been collecting? And it also includes the quality assessment, and will be, unfortunately I don't have time to go into detail on that. It's a very important step to look at the quality of your data, and if we have time later, please ask questions on that and I can share additional information with you. So the National Bicycle and Pedestrian Documentation Project has been going on for about 10 years now, I think. And they have a website, and they've encouraged communities around the country to start counting just with volunteers out on the street. 2-hour counts, usually 5 to 7, Monday, Wednesday, Thursday, and they focus most of it on mid-September, which is a great time to count, and they've suggested other times and weekends and throughout the year as well. They have a quarterly counting program for people who have more time. So this has caused a lot of communities to start counting, which is great, and so you may have some of those counts in your community already, and that's a good place to look for count data. Another good place to look is your parks department, or there are often all sorts of communities that are in groups within your community that may already be counting bicycles and pedestrians. And for example, this is an infrared counter where it's located on a pole and so easy to move, or you can have them permanently installed. And anything warm, any warm body that goes by, it will count. So this counts bicyclists as well as pedestrians. But this is a start. It's a good start to your data program, and you want to look for other, maybe even health departments who may be collecting this data. Inductive loops are another technology. We talked about that for motor vehicles, but they can also be used for bicycles if the sensitivity is properly set, if the loops are of the right configuration. And here are a couple examples of where that could happen in a bike lane. And this is an example of combining the infrared and inductive loop counting. There's quite a bit to be said about different technologies, and I'm not going to go into detail. Unfortunately, I don't have time to talk about all the different technologies, but I wanted to introduce you to these basic ones that are pretty common in our field, and point out this combination in particular because here you have counting all the warm bodies with your infrared, and you also have inductive loop that counts all the bicycles because they have metal in them. And yes, even the ones with the carbon fiber usually have enough metal in them to be detected. When I've tested that, it has not been a problem. So here you can subtract out the bicycle counts from the warm bodies and get then an estimate of your pedestrians and your cyclists at the same location. And this one happens to be in Virginia, in Arlington. Okay, so you gather up all the data you can find of all the different sorts and types. And then we're going to look at this permanent count program. Now the traffic monitoring program traffic monitoring guide gives, I think, 6, 7 steps. And I'm going to summarize those in this little graphic here. And the idea is that this is kind of an iterative process where we install stations, we look for patterns, we group stations. Do we need more stations? Well, we may have to install more. And we keep cycling through this. And then as we go, every year we want to compute the factors and apply the factors to the short duration counts. Okay, so let's start with the step of installing sites and selecting the sites. So going back to the example of Colorado, if you were a state, like the state of Colorado, you would look at different climate zones. So you want to understand that travel in the eastern part of the state may be different than travel in the mountain areas because the climate is so different. You're going to have snow at one time in this area and not in the other. So that's going to impact bicycle and pedestrian travel patterns. Another thing you should look at, urban versus rural. Of course, people in an urban area are going to have different travel patterns than those in the rural area. They might be, in the rural area, you may have more people doing day rides out for recreational rides. In the urban area, you may see more people commuting, although sometimes we do see people in the rural areas commuting. So those are just some things to be aware of. Another thing to look at is the volume of cyclists. For your first count, permanent counter, I recommend to find the highest volume locations you can, if possible a pinch point in your traffic flow. And those would be locations with over 600 bicyclists per day. This is data from Colorado, so I grouped all of the existing permanent count stations into high, medium, and low. And so over 600 bicyclists per day was high. And in some places, we'll need to also sample locations with less than 200 bicyclists per day, and those are kind of in the low category. And it becomes particularly problematic when you get into these very, very low numbers. It's very difficult to do statistics on that. So hopefully you can find some locations in the high and medium range, but also we, of course, will recognize that some locations may need to be in the low area as well. Okay, the traffic monitoring guide has provided this nifty graphic that helps us choose what permanent count technology to use and temporary count technology to use. So, for example, like we said, inductive loops, if I want a permanent counter for bicycles only, inductive loops are my thing. If I want a temporary counter for bicycles, I may choose pneumatic tubes. So that's a nice little graphic and can help you decide what technologies to use. Okay. Permanent count programs, we're looking at patterns. So once we have all that data, what patterns do we see? Here's an example of the Colorado data. We're looking at daily patterns. So we see Saturdays and Sundays are low for most of these locations, whereas we seem to have a high during the middle of the week at most of the locations. So that might be a commute pattern. People are using it during the week. And we see that there are a couple that have highs on the weekends. So we might call that a recreational pattern or a non-commute pattern. Hourly patterns, this is a typical commute type pattern. We have a high around 8 a.m. and another high for the evening commute, 5 to 6. And then a little bump around lunch. People might be going out for lunch. This is a typical non-commute pattern where we have more of a peak in the middle of the day. And I say non-commute because I don't know whether people here are going out for shopping trips or whether they're riding recreationally. And similarly with the hourly commute, some of those people are probably doing recreational rides before work or after work as well. But because the hourly commute pattern is centered around the traditional commute times, a lot of them are probably commuting to work. So there's the non-commute pattern. So we want to look for these patterns and then group our stations by those patterns. So we talked about all these different patterns for the daily. If we have double hump, that might be a commute pattern. There's some in between. Some of our stations are kind of in between. And then there's a non-commute pattern. So then the weekly, we just talked about that with the highs during the week for the commute and the highs on the weekends for the non-commute or recreational. And then we also have annual patterns, so you look at the traffic over the whole year. Some locations may have more variation with the season, and some locations may have less. So generally, commute locations have less variation over season, and non-commute locations would have more variation over season. And we saw this especially for the Colorado locations that are in the mountains where the snow prevents people from riding in the winter. Okay, so I grouped these, all the commute locations together, the in-between mixed kind of locations, and then the non-commute locations. And then when we apply this to the short duration counts, we need to group them as well. So we would take that weekly pattern. If the weekends are higher, we would say weekends are higher. If it's a rural mountain trail, it's in this mountain non-commute group. If the weekends are higher but it's not a mountain trail, then it could be in this urban plains non-commute group. And if the weekends are lower, so then we have a commute pattern, we would put it in the commute group. So that's a way to classify all your count stations. And why is that important? Because when we go to compute the factors, we want to group all the permanent count stations together and average those factors together to make a more robust set of factors. And when I'm talking about factors, now we're going to this is the traditional way of looking at factors. There have been some great papers in the last TRB that talking about how we can innovate with factors and create better factors. But I'm going to just present the traditional method from the traffic monitoring guide where you have a daily factor. You know your short-term counts that you counted for 24 hours, for example. Then you're multiplying it by this daily adjustment factor. That's how much is Tuesday might be more than the average, or how much less Saturdays might be than the average. And you multiply by a monthly factor, which is how much less or more a given month is than average. So if January is lower than average, this will adjust for that. So let's go into a little explanation of what a monthly factor, how that's computed, just to give you an idea. So you start with the annual average daily bicyclists, and this is just like the motor vehicles. You take the 365-day per year count, divide by 365 to get the average day of the year. And similarly, the monthly average is just the total counts for the whole month divided by the number of days in the month. Okay, pretty simple so far. Then let's take the example of June in a mountain community. So in June, the average, well actually the average for the whole year is 500 per day. That's average over the whole year. Well, we know there aren't very many people using the trail in the middle of the winter. So in June, it turns out there are 1,000 per day. So that would give us a monthly factor of 0.5, which means that the daily counts in June are twice the average. So that's just to give you a flavor for what these numbers mean. And here are the factors we came up with for, I think it was 2011 in Colorado, just to give you an example of what a set of factors might look like. And we have, again, these three groups: non-commute, mountain, and the commute pattern. Here's the 0.5. So this is our location where June is twice as high as the average. Here's October for our non-commute locations in the Front Range, and that's the urban plains area, is about average. Same thing with our commute locations. So October seems to be about average. So that's how those factors work. Now, we're grouping all of these together. So all the commute stations, we're computing the factors and averaging them. And that makes for a more robust set of factors because we need to generalize these. We have them for specific locations, but we want to generalize these when we apply them to the short duration counts, which might be kind of different. So that's why we're grouping them and averaging them. And the question is, how many stations, permanent count stations, do we need to create a robust set of factors? Fortunately, in Colorado, when we were looking at that, we had enough factors to actually answer that question to some extent. So this is an area of research, and a lot of people, I'm sure, are continuing to look at this. But this is my first cut at looking at it from the data we had in Colorado. So we want to have the tightest precision level we can. And we see that at around 7, 8, 9, it seems to bottom out. So that's probably about the tightest precision level we're going to see, which is near the 10% we'd like to see. So I usually recommend at least 7 permanent counters in your group. That would be in an ideal world. So that's one way to look at it, and we'll continue to learn more in the coming years as more people look at this type of data. And the traffic monitoring guide recommends 5 to 8 permanent counters for motor vehicles. But they recognize that for non-motorized, we may end up with, we'll be lucky if we have 3 sometimes. So some permanent count data is definitely better than none. So then we would rotate back to selecting sites and installing more if we need more. So that's how permanent counters tell us about the variation over time. Now let's go to short duration counts and understand the variation over space. So short duration counts, I'm going to go through the steps that the traffic monitoring guide gives us. What kind of counts, select the locations, and there are many details to this that we won't have time to discuss. But I'm going to touch on it lightly, and you can look at the reference for yourself. So what kind of counts? There are 2 basic kinds I want to tell you about if you have not are not already aware. Turning movement counts, which would be at an intersection. For bicyclists, we'll have the right turn, left turn, straight through motions, and we also need to look at the crosswalk traffic. And for pedestrians, it's mainly the crosswalk traffic. And then screen line or segment counts, I will call them segment counts to avoid confusion with other terms. So a segment count is any time a person crosses this imaginary line that across the road. So that's why sometimes we call it screen line. Anytime someone's crossing that line, they are counted. Okay. Many technologies available for this. Of course, the human with the clipboard is always works, and the nice thing about that is you can also look at if people are wearing helmets, are they male or female, those type of questions. You can also record with video and watch it in the office later. That tends to be the most accurate. Infrared, like we talked about, pneumatic tube counters for bicyclists. And again, the traffic monitoring guide provides this nice graphic to help us choose technologies. So we want to select count locations. Much could be said on this topic, but I'm going to just talk about a few things we want to consider. A variety of facility types. We have paths, we have on-street. We want to consider those different situations in choosing, and we want a variety of both, ideally. A variety of land uses, business districts, residential, university. These each might be different, and we want to look at all of them. And technology-related criteria. And fortunately, we have some further guidance in the traffic monitoring guide on that. Okay, how long should we count? Well, I took the count data I had where I had 365 days a year, and I played a little game. I said, okay, I know what the annual average daily bicyclist here is. What if I only knew 1 hour of that? If I tried to estimate it based on my the factors I've created. So if I only know 1 hour, I could have 60% to 40% error. That's pretty high. So how long do I really need to count before I can get a decent estimate? And I found that about 1 week, I'm down to 30 to maybe even 15% error. So that's pretty good. So I usually recommend 1 week, because after that, you're not seeing a huge change in the error. So I think that's kind of your optimal number. Of course, if you haven't been able to do that, don't throw your counts away. They can still be useful. Oh, and I want to say one more thing here. There's been some great additional research that has been done at the latest TRB, and it's great because they show very similar curves, and that's been done by Steve Hankey and Greg Lindsay in Minnesota, and the team at McGill, Tom Nozel, and Luis Miranda Moreno. Okay, short duration counts. We've talked about how long we want to count, but when should we count? So I did looking at the error, the same error in AADB estimates, same metric. Look how high the error is when we count in February in Colorado. And this is not the mountain locations. These are on the plains where temperatures are cold but not super cold. So 70% error if we count in February. And this is assuming we had 3 hours of counts. But when we look at the summer months, we see that there's much less error. So based on this, I usually recommend May through October as your best counting months. But generally, it's the times when you have the highest volume. So if you're in a southern area where you have much hotter temperatures during the summer, you may not see high volumes, and you may have a different pattern where you want to focus on spring and fall. But for maybe Midwestern climates, I think I'm safe saying May through October are good times to count. And this might be a wider span as well for more temperate climates like in Southern California. And I also want to point out here that for July, for example, even with the 3-hour counts, we're seeing less than 20% error. So it really impacts the error we can see. Great. Permanent count program. We have our short duration count program. Now we just apply the factors, plug and chug in our equation, and out pops the annual average daily bicyclists. And this is the work that's been done by the Boulder County Department of Transportation. They have counted bicyclists all around their network, and now you can see where you have the high volumes of bicyclists. So the green line here indicates the thickness of the line is the number of cyclists. So you see that in this road here, you have a lot of cyclists, and same thing here. And some of these other roads, it's surprising, these are nice and flat, but they have very, very few cyclists, relatively. So this really helps transportation departments start understanding, okay, if I want to do safety improvements, perhaps I want to focus on these areas where people are using them most, maybe. If I want to improve the conditions for cyclists, that might impact the most cyclists. And it starts to get you thinking, wow, in some of these locations, a high percentage of the traffic on the roads, talking a third of the traffic on summer days, are bicyclists. And that's going to make the department start thinking differently about what the use of the road is and who the primary users are. So it's very important to start opening our eyes, because often if we don't know, if all we know is I haven't seen a cyclist here very often, and you might make the mistaken assumption that there aren't any cyclists there. And that's a dangerous assumption, and it's usually incorrect. So as we do these counts, it opens all of our eyes, and helps us understand how to address cycling. And as we continue on this work, they want to build out their network and sample more of their roadways so that they can compute the vehicle miles traveled for their entire network. And that's bicycle vehicle miles traveled. So let's wrap up. Again, we have a traffic monitoring guide, and it gives us these two basic elements, this permanent program and the short duration program. And the reason we do those both is because the permanent program is too expensive to put everywhere. So we do the short duration counts so that we can get spatial variation without having to put permanent counters everywhere. IBPI has created a nice website to introduce this guide, the traffic monitoring guide, and to add information and help us all keep in touch with the latest research. So the traffic monitoring guide isn't going to change until the next update, but we can add content here and tell people what the latest information is going on. So we have a page for each of the steps in the traffic monitoring guide, and I hope that that will be a useful resource to open up the traffic monitoring guide and help us use it better. Okay, so we need both of these permanent and short duration programs. If you don't have a continuous counter at all, we really need one because we can't understand temporal distributions at all without that. If you have a choice and you can choose to do 1 week of short counts at each location, please do. And if you're in the Midwestern climate, May through October are good times to count. You want to choose the short duration count times carefully and focus on the times when you have the highest volumes. And I almost want to say don't even bother to count in times when you have low volumes because you're going to be just wasting your time because the estimates can be so far off. And this last one, I really want to focus on integrating bike counts into your traffic data. When you can, the same people who are collecting your motorized traffic data can collect your bicycle and pedestrian counts. They are out there anyway. If they can collect the bicycle and pedestrian counts, it's a good use of staff time, and these are people who know how to deal with traffic counts. They know how to deal with the equipment. They know where to put it, to preserve the data, to use the data, to allow access for others. So integrating these two count programs, I think, is very important for our budgets and efficiency. Now I'm just going to give a little example of how we can balance. We need to balance the permanent program with the short duration program. And like I said, it's an iterative process where we're going through this until we feel we have enough stations. So let's start with an example of how I'm going to start a new program. How am I going to balance these two elements? Well, let's say for the first year, I have one permanent counter. And then I got budget to install one counter, just like Krista said, and that's great. But I had a lot of enthusiastic volunteers, and so I organized a manual count, and we did the 2-hour counts just like they recommend in the National Bike Ped Documentation Project. We were counting September and 5 to 7 p.m. on Tuesday, Wednesday, and Thursday. Great. That's a wonderful way to start. And then the second year, I got a little more money, and I was able to purchase a short duration automated counter, which I rotated around all summer long, May through October, at all sorts of different locations, and I got 24 locations. So now, not only do I have a sense of the volume over space, but I know that each of those sites, what type of pattern. Do I see a commute pattern? Do I see a non-commute pattern? And I couldn't get that before with just my manual counts. So I expanded again the next year, and I based on those 24-hour accounts that or the 24 locations where I had a whole week of data, I was able to choose a set of new locations for permanent count stations. Locations that had pretty high volumes, locations that were representative of certain patterns. So now I have 5 permanent counters, and I bought one more short duration counter, so now I can sample 48 locations with my short duration counts. Then the next year, I realized there was one type of pattern that I wasn't really getting and I wanted to capture, so I bought one more permanent counter and I put it at that site that really, maybe it was a school pattern and I really wanted to get that in, understand that temporal pattern. And then I bought more of these automated short duration counters that I could move around. So I'm moving around my network 1 week per site all summer long, and I realized that's a really effective way of getting a much wider area in my count program. Then I'm going to skip all the way to the last year. So I installed another 6 permanent counters over the past 5 years before the 10th year. I've got them on all different types of facilities and different types of patterns, and I've got, a pretty good set, 3 or 4 per factor group. Krista recommended 7, but hey, I've got 3 or 4. It's pretty good. And what the great thing, now that I have this robust set of factors from my permanent counts, I realized I don't have to count every year at every location. I can start rotating. I put all my short-term counts on a 3-year rotation. So now I'm only counting that site once every 3 years because I know what those temporal patterns are based on my permanent count programs. And that increased my number of counters, stations that I can do my short duration counts to 720. 720 stations I can now get using my short duration count program. So that's a huge, just imagine, that's huge on a network. I'm getting a lot of the major facilities with this count program. So that's just an example of how a count program might evolve over time. It's certainly something that builds and grows, and how you might balance those 2 elements. Okay, so ongoing work. Many states are continuing work on this. Colorado was a pioneer and still continues to be, but many states are also developing programs. Washington has a program. The TRB, Bike Ped Data Subcommittee, is a good resource. That website, Liz Stoltz is the chair of that, and it updates the website pretty well to give us more resources. FHWA is including bike and pedestrian counts in their motor vehicle database, where all the motor vehicle traffic data lives. This is huge. That means that bicycle and pedestrian traffic data will be with motor vehicle traffic data, where all the traffic data should live. So this is a very exciting development. In coming months, we expect to get the final report from the NCHRP 7-19 project that will tell us more about the accuracy of technologies, different technologies for counting bicycle and pedestrians. So that's an exciting thing. I think it'll be coming out in June, so look for that this summer. And I ask, because all of you have great information and I'd love to hear more about what you have to share, not only will we have the discussion today, but I'm going to create a Google group. We at IBPI will create a Google group for continuing that discussion and sharing the knowledge each of you have, because there's so much that's being developed in this evolving field. And OTREC is next month starting a bicycle and pedestrian data archive. This is a place where we can put our bicycle and pedestrian data, except it will accept different formats, and that will be coming out in the next year or 2. So that's an exciting place where we can store data and get it formatted to go into the TMAS system that FHWA has. Okay. So I need to thank all the people who've helped me along the way, my friends who stood out with me in the cold to help validate the counts were working right. The TRB Traffic Bike Ped Data Subcommittee with Liz Stoltz, the data provided by the Colorado DOT, all the great work that's being done in the city, at the city and county of Boulder, and the continuing work with ODOT and WashDOT and a lot of other great people in Oregon. So thank you for your attention, and I will now open it up to questions, and I look forward to hearing them.
Thanks, Krista. So we have about 15 or so questions, and I doubt that we'll be able to get through those questions in the next 15 minutes. So taking the questions in the order they were typed into the chat screen, the first one is, how do you decide the cut points for what would define high, medium, and low volume categories?
So I looked at the count data I had for Colorado when I showed that slide with all the volumes, and I just plotted those, the annual average daily bicyclists for all the locations I had, and I'll go back to that slide. So I just averaged all the counts for each year, and I found that they kind of broke into these natural categories of less than 200 and greater than 600. So this was just based on the Colorado data, and when I looked at just one city, I looked at Boulder's data first. I found these patterns. And then when I looked at the whole state as a whole, I found the same patterns. And so I thought, this might be a generalizable thing. So it'll be interesting as we look at new communities, whether we also see that. When I moved to Oregon, I started looking at that. And of course, the Portland bike counter is 4,000 bicyclists per day. So it's off my chart. But that is not terribly typical for the U.S. So I think this might be a useful thing for many other communities in the U.S.
So this one relates to the permanent count stations. So could you expand on how other jurisdictions select sites for permanent counts? So for example, you have one counter to install, but 3 possible locations. How do you go about choosing it?
Okay, so you want to know where to put your first permanent counter or your second or your third. Am I hearing that right? So for the first counter, I recommend always, if you can find the pitch points, for example, the city of Portland wisely chose one of their high volume bridges. All the cyclists have to go through there. It gives you really high volume count data, which is more robust for creating factors. So those are good sites. If you have pinch points, choose those for your first permanent count stations. If you don't and you have more of a distributed network, which was the case we looked at in Boulder, then find locations that you do have relatively high volumes if you can. Paths sometimes can be good locations, and they can be good for the counters themselves depending on what technology you're using, but often a path, it focuses the traffic in one place, and it can be easier to install if you have electricity running to it. Anyway, there are lots of issues. So it also depends on the technology you're using. Yeah, so if you're using inductive loops, you need to be aware of where the electric lines are. You don't want to be near too much electric lines because that can mess up your inductance measurements, especially because bicyclists you have to reduce or increase the sensitivity, and so it becomes more sensitive to those types of issues. And there are a lot of other factors that I could talk too long about. So there's some great guidance in the Traffic Monitoring Guide, and our website also provides further guidance on that sort of thing.
Okay, so the next question is coming from somebody in Albuquerque, New Mexico, and the question is, how do programs use ped bike turning movement counts? So I'm just reading what was typed in the chat. They have a lot of scrubbed down intersection turning movement counts, and they're struggling between should they continue short duration intersection turning movement or scrub down. or with all the crazy movements between ped and bikes, or move away and look at only mid-block link counts?
So a lot of us are dealing with that question. I dealt with that question when I did my my dissertation. I had also turning movement count data, and I also scrubbed it down and just used the total count for the intersections because it was just easier to work with. So the nice thing with the intersections is that you can, for one person standing out there, get multiple approaches to the intersection, and if you have the ability to use that data, that's great. There are advantages with just using a simple segment count, though, because it's simpler for your volunteers, even if you're doing a manual count. And it opens the door to using automated technologies. It's easier to apply automated technologies at the mid-block locations. And like I said, there are a lot of advantages, as I've pointed out, to having a longer than 2 hours, which is really the most you can expect someone to stand out there and accurately count. So there are a lot of advantages to moving to the mid-block locations. There are some automated technologies that can be applied at the intersection, and they've done some great work on that in Oregon, where they're looking at just using pedestrian push buttons as a way to estimate pedestrian activity. So that's an interesting approach. And also using the existing inductive loop detection that they're using just for the signal detection to tell the signal when to turn on. If those are approaching the intersection, you could then use those for counting as well. And the City of Portland is doing that. And we're working with ODOT, Oregon Department of Transportation, on possibly doing that themselves. So, so there can be ways to actually automate your turning movement count, or your intersection counts, I should say. They're not really turning movement counts. But for Albuquerque, yeah, I think moving towards an automated count program at the mid-block where you can get a whole week or a whole 24 hours of data would be really advantageous, because then you can see the pattern over the whole day.
So this is an equipment-related question. What equipment do you recommend for temporary cyclist counts in the road? Not in the bike lane, but a cyclist in the roadway. So this agency is thinking of using video counters to discriminate between cyclists and cars.
So I am aware of at least one jurisdiction, probably many, who are doing that. And as with all of these technologies, I mean, I knew we would get into technologies because they all have their issues, and none of them are 100% perfect. I'm going to give you the example of what was done in Denver. So they tried using their video cameras that they had lying around that they used for signal detection. And they found that didn't work well at first. But as with most of these things, if you fiddle with it long enough, you may find something that does work. So what they found was that they got this Iteris video camera, and they pointed it directly down at the bike lane, and they were able to use that because there were very few cars going into the bike lane here, and the bicycles were pretty well using it, and they weren't stopping there. They were continuing on, and very few pedestrians were crossing it. So that kind of worked. There are new video, this was many years ago, and there are now new technologies that can better differentiate. And I think the questioner was really asking about, what about if we don't have a bike lane, and what if we're trying to differentiate in the roadway? And I've heard there are technologies. I have not heard that any are really robust yet, but there are video image recognition programs that are starting to do this, and I really look forward to seeing that field develop and become more strong. So if any of you have positive experiences with that, that would be great if you can share that. And like I said, we'll create this Google group so we can all share our experiences and learn from each other.
So as far as adjustment factors, this question relates to that. Do you adjust everything to the highest use month? So, for example, did you pick June because it had the highest AMDB?
Okay, that's a great question. So, no, we are adjusting to the average. So the idea here is not to adjust to June or to adjust to even October. October happened to be about average, but what the idea is to adjust to the average. So if we count all year round, we know what the average is. At our sites where we're not counting the whole year round, so we're not going to adjust to June, we're going to adjust to what the average is. So in the case I gave you, October happened to be the average month, but we're not adjusting to October. If it didn't happen to be average, it wouldn't matter. So I hope that answers the question. We're adjusting it not to a particular month, but to the average daily count for the whole year.
So I'm thinking this question may have been answered through the chat discussion that you may have not seen, but I will ask it anyway, just in the event that it wasn't sufficiently addressed. Are the Colorado factors presented appropriate to apply to current short-term counts in rural Colorado areas?
Are they appropriate to apply to short duration counts in rural Colorado? The factors the grouping I had was for mountain non-commute. So if you have a mountain non-commute rural area, yes. So those factors were based on what happened in Aspen, Colorado, and what happened in Vail, Colorado on their path network. So if you have a similar facility in that region, yes, those are great factors. If you have a location in rural eastern Colorado, no, don't use those factors. And it may not even be appropriate to use the factors we found from the Front Range because the Front Range were urban areas mostly or suburban areas. So those didn't really include the rural areas. So I would recommend, if we want to know what patterns should be applied in the rural areas and what factors should be applied in the rural areas, we probably need to put in some permanent counters in the rural areas and start creating factors specific for that type of area.
So in the slide where you were talking about grouping counters, when you suggest 7 per group, how do you define a group?
So that's a great question. That's why remember how we were talking about all those different patterns, and I was showing you all these different patterns. So I'll go back to this. And I said, this is a group. We have the in-between, we have the commute, pattern for the weekdays, we have the annual pattern. So I define all locations with the patterns I've circled here to be in that group, and I'm calling that group mixed. That's the mixed group. And then I have another group where I have all the non-commute patterns. So all the stations that have those patterns, I'm grouping in that group. So that's how I'm selecting that group. And then when I go to the short duration counts, so now I won't know what the monthly pattern is because I only know what's going on for a week at these locations. But I have the weekly pattern because I have sampled for a week at each of these locations. So then I can group them and say, okay, if my weekends are higher, then I'm going to go this way. If my weekends are lower than the rest of the week, then I'm going to go this way and go to the commute pattern. So this is how I would classify the short duration count locations. Is that clear? Okay, hopefully. And if not, there are lots of resources on the website and links to the report where I go into too much detail on this topic.
So unfortunately, we have about 9 more questions left and about a minute left of the webinar. So Krista will answer the rest of the questions offline, and we will share those answers with you. There was also a question regarding the presentation. We will also make that presentation presentation available to all of those who attended the webinar. But this concludes our webinar, and I just wanted to thank everybody for taking time out of your day to join us. So since this is our first webinar, we are looking for your feedback so that we can improve and offer more relevant webinars for you in the future. So we'll be emailing you a short 5-minute survey to get your thoughts and ideas of topics for future webinars, as well as your experience with this first one as well. So you can view our other IBPI professional development offerings on our website as well, and I just wanted to thank everybody again for attending our webinar today. And thank you, Krista, for taking the time to share with us your experience with counting programs.